Hi, today we're going to talk about the ViewController object specifically in our L Systems application. I have here the ViewController.zib file, and you can see that this consists of a number of text field objects. And we have text fields, we have 8 text fields here with labels. I have a text view here, and this is different than the interface that I showed you in the PDF file, the documentation. I decided to put a text view here so that we could see the entire string as it was developed. And then I have a slider for iterations, and then a label field that shows the number of iterations currently on the slider. And this slider has a range, a minimum and a maximum of 1 and 10, and its current value is set to 1. I clamp it to 10 because these L system strings, especially in fairly complex rules, can get very large. So we want to clamp it to 10 to make sure that we don't exceed some sort of maximum memory requirement as we build our string. C strings, as we know, are not clamped as far as memory is concerned. We can have a C string that fills all of memory. The only requirement of a C string is that it be terminated by a null. But we need to watch the memory in our application to make sure that that string doesn't poke out of the heap, or I'm sorry, poke out of the stack in this case, and get into our data for our application. So we want to make sure to keep this string below a minimum level. And I've hard-coded that level. When we look at the display view, I've hard-coded that level to be 65,536, I believe, so bytes. And then, of course, we have 2 buttons. And these are wired up to objects and methods in our ViewController class. So we can see these wirings here. We can see all of the text fields are wired up to a dismiss keyboard method, as it should be, on did end on exit. Count change is wired to the horizontal slider's value changed event. Display pressed is wired up to the touch up inside event on that button, and then go pressed is wired up to the touch up inside event of the go button. So now let's look at ViewController.h, and we'll see that we have imported Display ViewController. Display ViewController only exists so that we can push it onto a UI navigation controller object that we're going to talk about in the 3rd video. But this UI navigation controller object needs a view controller, not just a view, but a view controller to push onto itself so that we can display the display view UI view. So that's the only reason Display ViewController exists. We have properties. We have the property Display ViewController, and then we have all of our outlets. We see here that we have our 8 text fields, our text view, and then our counter label. And then we have 4 methods: dismiss keyboard, go pressed, display pressed, and count changed. Count changed is going to happen when the slider value changes. Display pressed on the display button press, go pressed on the go button press, and then dismiss keyboard, of course, is just going to call resign first responder on all of our text fields when we hit the return button in the keyboard. So let's look at the implementation. And we're going to start right at the top. So now we synthesize all of these properties. When I synthesize properties, I like to group them according to what they are. So all of our text fields are synthesized in this statement, and then result and counter are labels, and we're synthesizing those. Actually, result is now a text view, but that's okay. And then we synthesize Display ViewController. And then, of course, we lazily instantiate Display ViewController by calling its getter and then instantiating it if it doesn't already exist. And this is a classic method, especially in Objective-C, to go ahead and alloc and init it if it doesn't already exist. Dismiss keyboard is a simple resign first responder on sender. Go pressed. Now here we go. This is the method that I spent a great deal of time in the documentation talking about. So we have two buffers, our output buffer and our string gen buffer. And then I also have a buffer here for a one character string. A one character string is going to be if we pass the character in the string straight through without using a replacement rule on it. Now, the output buffer here is 65,535 long, bytes long. Now, the size of character, which turns out to be a byte. It's an unsigned int in the range 0 to 255 in C, but be that as it may. If we set the first character of a string, of a char star, to 0, \0, which is the null character, then that will effectively truncate the length of that string to 0. Because the only thing that tells us the end of a C string is where that null character is. Then we have a Boolean to detect if the string is going to exceed the length of the buffer. This is to keep us from having C runtime errors, which are very difficult to track and trace. So, especially in Xcode, we avoid this situation by taking the sum of the length of the two buffers. We attempt to add them up, and if that sum would exceed our hard-coded 65,535, then we set this Boolean to yes, just display an alert view and fall out. So now we copy. String copy is a C function that copies the content of one string into another string. So here we're telling it, and string copy takes two arguments, the target and the string to copy into the target. So we take the text right out of generator, that first text field, and that text field is this guy right here. We take the text right out of that generator and put it into string gen. And then we do it as a UTF-8 string, which gives us a C string representation of this NS string object. And then we get rule 1a, rule 2a, rule 1b, rule 2b in the same way. And these are constant characters. They will not be changing. Then we find out how many iterations have been set by the slider. And we count through a for loop according to the number of iterations set by the slider. And then we step through string gen. This is our C string. We're just going to step through the C string. The index is going to be C. So we're starting at 0, and we're going through until just one less than the length of string gen, and then adding 1 to C each time. And then we're going to look to see if the string exceeds the assigned length of the buffer. And if it does, we're going to set that Boolean to yes, and then rather than breaking out of the inner for, we're just going to call a label, or go to, out. And our out just checks if error, and then puts up an alert view if that's the case. And then it returns. In other words, if it's going to be too long, don't add anything to it, just truncate it right there, and clamp it to the last successful length, and then just bail out of the method. The heart of this method is right here. So we look to see the first character of rule 1a. There should only be one character in rule 1a. So we're going to replace a character with a string. Rule 1a will only have one character, and it will be at index 0. So we look at the current character in string gen and compare it with the first character of rule 1a. And if that is the case, then we have a replacement. We use string lcat here, and you can look this function up. The string lcat will copy at most the length of, in this case, the output buffer characters into output buffer. So we copy that in, and then we copy rule 1b into the output buffer. Otherwise, if it's 2a, then replacement has been found for rule 2, and we copy rule 2b into the output buffer. Otherwise, we didn't find a replacement, so we just copy the one character string into the output buffer. Now, one character string first has to be set up. So the first character of one character string is the current character in string gen. The second character is the null character, and then we can copy it as a string and using string lcat. And that way we don't have to fiddle with where the null is in output buffer. We already talked about the alert view. Then we copy the output buffer into the string gen. So now for each iteration, we go through, we fill up the output buffer, and then we copy it into string gen for the next iteration. And then we go ahead and truncate the length of the output buffer to 0 again. We set the result text to the context of string gen, and then we put that into our result text view. And then we send that result text to the display view controller's views display string property. And the display view will actually do the drawing with the content of this display string. Display pressed sets up that view. It pushes the display view controller to self navigation controller, and then it sets the positive angle to the value in the text field that we have, and it has to multiply this by pi over 180 because angles it expects to have in radians rather than degrees. And then likewise for the negative angle. And then it sets, because when we push it, that display view or display rect is going to be called in our UI view controller, display view. And then we want to make sure that we use set needs display so that this angle can be incorporated into the display of our view. Count changed merely sends it merely sends string with format with the sender's value, which is the slider's value, as an integer. It sends that back to the counter text. Now counter, remember, is a UI label sitting next to that slider to show the value of the slider, the current value, integer value of the slider between 1 and 10 inclusive. View did load, we just set the title, because remember all of this is wrapped up in the UI navigation controller. We set the title of the view controller to settings. View did unload, it's very important to release all of our outlets, so we do that here. And then of course should auto rotate is set to its normal content. So that's really it. That's all I really wanted to get into today. We can of course look at display view controller, but as I said, this exists only as a view controller to house display view so that it can be pushed onto a navigation controller. We import display view, and then display view is instantiated here, and then we also have a display string property that gets passed through, and then in it with nib name of display view controller, we set the title to display. We initialize it with a frame of the main screen's bounds. We set this view property, display view controller's view, to display view, and then we set its background color to black. And that's really all we do here after synthesizing our two properties. So that's it for this discussion. The important thing is that everything here, the view controller and the display view controller, are both children of the UI navigation controller, and we have looked at how the string gets iterated for each value of the slider. Thank you very much.